Hi and welcome to Kang Academy. In the last video, we learned about the history of the Civil War. In this video, we're going to learn about the physics of the Civil War. Okay, so first things first, the Columbia cannon here fires at 622.706 meters, and it takes 1.88 seconds for the cannonball to reach its target. If we fire off of a 50-meter high cliff at a 1-degree angle, how far can we shoot, and what will the final y velocity be? I've taken the liberty here of plugging two equations into this formula right here. So we get the final, the initial velocity of x at 331.227 meters per second, and I get the velocity here, initial y velocity, at 9.22 meters. Okay, we are solving for Vy final right here, and we're also solving for change in x. Okay, so Vy final, let's use this equation right here, is equal to V initial squared, which is 9.2214 squared, plus 2a, and we know our acceleration in the y direction is always negative 9.81 meters per second, times change in x, change in y in this example. So what is change in y? Change in y, because we're up on a 50-meter cliff, is 50 meters, right? Because there's a displacement in the y direction of 50 meters. So let's take that, negative 50 meters, right? Okay, negative 50 meters. Let's take a calculator to this one. Okay, so let's see, 2 times 9.81, negative 9.81, times negative 50. That equals 981. Then you add that to 9.2214 squared. That equals 1066. Take the square root of that on both sides to get V by itself, and you get V is equal to 32.561. Okay, so V final is equal to 32.561 meters per second. Okay, great. Next, let's solve for time. Why solve for time? Well, if we're looking for displacement in x, then we need t in this example. We have everything except t. So let's solve for t. We're going to use this equation right here because we know all of these variables. So we have 32.561 meters per second is equal to the initial y of 9.2214 meters per second plus acceleration times time. So again, the acceleration should be negative 9.18 meters per second, and time is what we're solving for. Okay. Then we take, this should be negative because it's in the negative direction, right? So the y initial is positive because we're going upward. It's in the positive direction because it's at a 1-degree angle, and then it shoots downward. So that means it's at a negative. It's in the negative direction. So 32.561, let's see, negative minus 9.2214 is equal to negative 41 approximately, and then we divide by 9.81, negative 9.81, which gives our time at 4.26. So 4.260, shut up! 4.260 as our time. Right, okay, so then let's solve for x. Change in x is equal to V naught. V naught for x I solved before, so it's just 331.227 meters per second times time, which is what we have here, 4.260 okay, plus, what is that? 1/2 acceleration. Acceleration in x is always 0 because it's constant, which means that if we plug this in, we get 0.227, 14, so 1410, 1410, 0.70750, 0.750. Okay, and we can just plug it in here. For, I guess you can't see that. 1410.750 meters. And we have the y final as negative 32.561 meters per second. Okay, thanks for watching.